Standing before the pyramids of Egypt or the temples of Angkor Wat, it's hard not to feel a sense of awe, not just at their size, but at the sheer impossibility of their precision. These aren't just piles of stone, they're masterpieces of engineering, built with mathematical accuracy that rivals modern technology. And here's the mystery. The people who constructed them left no textbooks, no detailed blueprints, no step-by-step manuals. So how did they pass down the knowledge to build these wonders across generations? The answer lies not in dry instruction manuals, but in something far more captivating: myth. Think about the stories you've heard since childhood, tales of floods, of gods shaping the world, of celestial beings guiding human hands. What if these weren't just fanciful legends, but carefully crafted lessons? Hidden within these myths are the secrets of civil engineering, encoded in narratives that could be remembered and retold for centuries. Flood myths, for example, weren't just warnings, they were survival guides, teaching communities how to manage water, build canals, and predict seasonal changes. The alignment of temples with the stars, those weren't random choices, they were celestial maps etched into stories so the knowledge wouldn't be lost. This is where the magic happens. Ancient societies didn't separate science from storytelling. They wove their engineering brilliance into myths, ensuring that every generation would inherit the wisdom of the past. Today, we're going to unravel these hidden lessons, peeling back the layers of legend to reveal the practical genius beneath. From the hydraulic systems hidden in flood narratives to the astronomical precision encoded in temple myths, we'll explore how stories became the textbooks of the ancient world. By the end, you'll never look at mythology the same way again, because these weren't just tales, they were blueprints for civilization. So let's begin the journey and uncover the lost language of myth and stone. Imagine holding an entire library of engineering knowledge in your head, not in dry equations or diagrams, but in vivid, unforgettable stories. That's exactly what ancient cultures achieved through oral tradition. Without pen or paper, they turned myths into living textbooks where every plot twist and character served a practical purpose. Take the Aboriginal Dreamtime stories, for instance. These weren't just tales of creation, they were meticulous guides to the land. A story about an ancestral serpent carving rivers wasn't mere fantasy. It was a lesson in hydrology, teaching where to build settlements safely, how water moved through the landscape, and even predicting seasonal floods. The details were so precise that modern geologists have found these narratives match actual geological events thousands of years old. But how did they ensure these stories stayed accurate across generations? The answer lies in the power of ritual and repetition. Myths weren't told casually, they were performed, often with rhythmic patterns, song or dance, transforming them into mental anchors. Think of it like a catchy song you can't forget. The rhythm and imagery made the information stick. In Polynesia, navigators used chants to memorize the stars, currents, and winds, turning vast oceanic wayfinding into something as simple as humming a tune. A single myth could encode navigation routes, storm patterns, and even the best times to sail, all without a single written word. And here's the brilliance: these stories adapted without breaking their core truths. When new discoveries were made, like better building techniques or safer trade routes, they were woven into existing myths, ensuring knowledge evolved without losing its foundation. The Inca, for example, updated their architectural stories as they refined earthquake-resistant masonry, embedding each innovation into legends of gods shaping the mountains. This wasn't just storytelling, it was a dynamic, living database, constantly refined yet never losing its original wisdom. What's truly astonishing is how these oral blueprints rivaled written records in accuracy. In West Africa, the Dogon people preserved astronomical knowledge of Sirius B, a star invisible to the naked eye, through oral myths centuries before telescopes confirmed it. Their stories contained orbital details so precise that modern astronomers were stunned. This wasn't luck, it was proof that myth, when crafted with purpose, could carry complex data across millennia. So the next time you hear an old tale about gods or heroes, listen closely. Hidden in the drama might just be the genius of ancient engineers whispering their secrets across time. Mathematics wasn't confined to dusty scrolls or chalkboards in the ancient world. It lived in the very stories people told around campfires and in temples. Take the myth of Daedalus and Icarus, for example. On the surface, it's a cautionary tale about hubris, but look closer, and you'll find a masterclass in engineering ratios. Daedalus didn't just slap wings together. He carefully balanced feather length, wax distribution, and weight, each detail a silent lesson in proportional design. Too much wing and the structure would fail, too little and it wouldn't lift. The story made these principles unforgettable, turning a father's warning into a timeless rule of thumb for builders. Even more astonishing is how sacred texts disguised math in plain sight. The ancient Hindu Vedas, composed in rhythmic Sanskrit verses, hid the Pythagorean theorem within the cadence of their poetry. Reciting these hymns wasn't just spiritual, it drilled geometric truths into memory through meter and repetition. Imagine learning algebra through song lyrics. That's exactly what these cultures accomplished. The Babylonian epic of Gilgamesh did something similar, embedding measurements for ziggurats in its poetic lines, so builders could reconstruct dimensions from memory alone. But why go to such lengths? Because stories transcend literacy. A farmer who'd never held a compass could still grasp the idea of right angles through a tale, or understand load distribution by hearing how a hero balanced a bridge. Myths democratized knowledge, making advanced concepts accessible to everyone, from stonemasons to children. And the most brilliant part, these narratives were self-correcting. If someone misremembered a detail, the plot would collapse like a poorly proportioned arch, forcing storytellers to preserve accuracy to keep the tale alive. Now shift your gaze upward, and you'll find the same ingenuity in the stars. Celestial myths weren't just about gods and monsters. They were navigation charts and architectural guides written in the sky. The Egyptians didn't align the pyramids with Orion's belt because it looked pretty. They did it because the constellation's movement marked the Nile's flooding season, a critical calendar for construction. Polynesian voyagers, meanwhile, memorized star paths through chants that doubled as sailing manuals, turning myth into a GPS. What's truly humbling is realizing these cultures didn't see science and story as separate. To them, the universe was a grand narrative, and every equation had a character, every principle a plot twist. The next time you gaze at an ancient temple or hear an old legend, remember, you might not just be hearing a story. You might be reading an ancient blueprint written in the universal language of human imagination. Celestial navigation wasn't just about plotting courses, it shaped civilizations from the ground up. The Navajo didn't randomly place their hogans to face east. They followed the hero twins myth, where the sun's path was literally stretched to bring balance to the world. By aligning doorways with sunrise, they turned dwellings into solar calendars, warming homes in winter and shading them in summer. This wasn't superstition, it was passive solar engineering, encoded in a story anyone could remember. Halfway across the world, the Egyptians took this further. Their temples weren't just aligned with stars, they were mirrors of the heavens. The myth of Ro's bark sailing through the underworld each night wasn't just theology, it mapped the Nile's flooding cycle onto the stars. When priests recited tales of Sopdet, the goddess personifying Sirius, they were also noting the star's heliacal rising, a celestial alarm clock signaling when to rebuild canals or prepare for inundation. The temple of Karnak's axis, precisely angled to catch the winter solstice sunrise, didn't need an architect's sketch. It needed only the story of Ra's rebirth, repeated until every mason knew light should pierce the inner sanctum on the shortest day. Even more remarkably, these myths standardized knowledge across vast distances. The Maya, separated by jungles and highlands, all built pyramids echoing the Popolva's cosmic tree, a story so precise it dictated stair counts matching Venus cycles. No central authority enforced these rules. The myth itself was the teacher. When Polynesian navigators chanted about Maui slowing the sun, they weren't just explaining daylight, they were preserving latitude markers. Stars that hung longer near the horizon guided voyages across thousands of miles, all embedded in an adventure tale. What's striking is how these stories balanced poetry with practicality. Greek myths described Atlas holding up the sky, but Theodorus of Samos reportedly studied the tale to calculate column loads for roofed temples. The weight-bearing metaphor became a structural principle. Similarly, Native American lodgepole builders didn't need trigonometry. They had stories of Spider-Woman weaving the universe, which taught the strength of triangular frames. Now shift from the heavens to the waters. Just as stars guided builders, flood myths held blueprints for survival, not as warnings but as hydraulic manuals etched into legend. Flood myths weren't just dramatic tales of survival, they were ancient civilizations' way of passing down hydraulic engineering through generations. Take the Mesopotamian epic of Gilgamesh, where the god Enki whispers flood warnings to Atrahasis. Hidden in that dialogue was a crash course in dike construction, how to layer reeds with bitumen, angle walls to deflect currents, and space floodgates to control overflow. The story made these techniques unforgettable, turning a survival manual into an epic. Over in China, the legend of Yu the Great took it further. His mythical battle against the floodwaters wasn't just heroism, it was a step-by-step guide to canal networks. The story described how he dredged riverbeds, diverted tributaries, and even used smoke signals to coordinate laborers across valleys. Every plot point served a purpose, ensuring that even a child could recite the principles of watershed management. But why wrap engineering in myth? Because water was unpredictable and mistakes were deadly. A dry season could starve a city, a misplaced dam could drown it. Myths turned these life or death lessons into narratives so gripping they survived millennia. The Aboriginal rainbow serpent didn't just create rivers, it taught where to dig wells in drought, how to read seasonal algae blooms, and why certain bends in a river were prone to erosion. Even the story of Noah's Ark carried hidden brilliance. The dimensions of the Ark, 300 cubits long, 50 wide, weren't arbitrary. They matched the ideal ratio for stable barges, a design still used in shipbuilding today. The myth preserved shipwright knowledge long before naval architects put it to paper. The real genius, these stories adapted to local landscapes. In the Andes, where flash floods carved mountains, myths described gods battling with landslides, teaching terraced farming to slow erosion. Along the Nile, Osiris's resurrection mirrored the flood cycle, with temples built at elevations marking safe zones. And in the Pacific, Maui's fishing tales doubled as tidal charts, warning when to avoid reef passages. Now consider what this means for us today. Modern hydrologists studying the Tigris River found that Mesopotamian dike placements preserved in myth align with satellite flood models. Chinese archaeologists uncovered ancient canals matching the great descriptions, proof that these stories weren't metaphors but oral blueprints. The next time you hear a flood myth, listen for the quiet wisdom beneath the drama. That's not just storytelling, that's civil engineering disguised as legend. From water, we turn to stone because myths didn't just teach how to control rivers, they taught how to make mountains stand still. The Inca didn't just build earthquake-proof walls, they told stories of gods testing mortar with tremors. Every myth was a stress test, ensuring the next generation would build smarter. Symbolism didn't just decorate myths, it built cities from the ground up. The Norse didn't merely imagine Yggdrasil as a cosmic tree, they saw it as the ultimate blueprint for stability. A central pillar, roots anchoring it to the earth, branches distributing weight. This wasn't just poetry. It was a lesson in load-bearing design, teaching builders to mimic its balance in mead halls and longhouses. When Viking craftsmen raised their massive wooden roofs, they didn't need engineering manuals. They had stories of gods shaking the tree during Ragnarök, reminding them to reinforce joints against storms. Across the ocean, the Maya took symbolism even further. Their myths described bridges as giant serpents, coiled and flexible. At first glance, it sounds like fantasy, until you realize their actual rope bridges swayed like living creatures during earthquakes, absorbing shock instead of snapping. The serpent wasn't just a metaphor, it was a technical manual in disguise. By visualizing bridges as beings that could bend and twist, the Maya encoded seismic resilience into every retelling. Even children playing with reed models learned without realizing how tension and flexibility could outlast tremors. But the real magic happened when these symbols scaled up to urban planning. Take Rome's aqueducts, engineered to last millennia. Their secret, they were built like the veins of Jove himself. Myths describe the god's blood as rivers flowing through the earth, branching and narrowing to maintain pressure. Engineers mirrored this in their designs, tapering channels to prevent bursts, just as veins thin toward capillaries. The symbolism wasn't decorative, it was functional, turning divine anatomy into hydraulic law. Inca cities took it a step further. Their legends spoke of Pachamama, the earth goddess, whose body was laced with sacred lines called sex. These weren't just spiritual paths, they were the original city grids, aligning temples, springs, and roads along invisible energy lines. Modern surveys reveal these sex-matched fault lines and water tables, proving the myths were geological surveys in narrative form. A storyteller chanting about Pachamama's veins was, in effect, reciting a civil engineer's map. Now consider how these symbolic lessons shaped daily life. When a medieval European cathedral rose skyward, its flying buttresses weren't just architectural flourishes, they were stone prayers, echoing the outstretched wings of angels in stained glass stories. The weight of the vaulted ceiling didn't crush the walls because the builders had internalized a simple truth from myth: wings lift. No wonder Gothic architects dared to build taller than anyone thought possible. They weren't just stacking stone, they were retelling sacred stories in 3 dimensions. From trees to serpents to God's veins, symbolism turned the abstract into the unforgettable. But myths didn't stop at single structures, they orchestrated entire cities, threading engineering through every alley and plaza. The next time you walk down an ancient street, look closer. The patterns beneath your feet might just be stories in stone. Creation myths didn't just explain the origins of the world, they laid the literal foundations for cities. Take Babylon's Enuma Elish, where the god Marduk slays chaos itself to create order. That cosmic battle wasn't just theology, it was urban design in narrative form. The story described the universe as a ziggurat, each level a distinct tier of existence, from the heavens above to the underworld below. When Babylonian architects rebuilt their city after floods or invasions, they didn't need blueprints. They had the myth, which dictated everything from temple heights to street widths, ensuring the city mirrored the cosmos. The result, a metropolis where every brick echoed divine harmony, from the grand processional way to the humblest courtyard. Halfway across the world, Hindu mandala cities took this idea even further. The ancient text of the Manasara didn't just describe city planning, it wove it into creation itself. Brahma's cosmic lotus became the template for circular cities like Jaipur, with concentric rings radiating from a central temple like petals. Each sector was assigned to a caste, not as hierarchy, but as functional zoning. Priests near the sacred core, artisans in middle rings, farmers on the outskirts for easy field access. Even the gates aligned with celestial directions, turning the city into a giant sundial. The myth didn't just inspire the layout, it enforced it. Deviate from the sacred design, and you risk disrupting the universe's balance. But here's the brilliance: these myths solved practical problems through symbolism. When Roman founders traced their city's boundary with a plow, reenacting the myth of Romulus, they weren't just performing ritual. They were encoding surveying techniques into legend. The furrow marked the sacred Pomerium line, a legal and defensive border that doubled as flood control, since the raised earth diverted rainwater. Similarly, Chinese legends of the Yellow Emperor's well-field system didn't just preach equity, they created a scalable grid for irrigation. 9 plots shaped like the Chinese character for well-ensured fair water distribution, with the central plot farmed communally to feed the state. The story made the math memorable. Even indigenous American myths shaped urban resilience. The Aztec tale of Tenochtitlan's founding, an eagle on a cactus eating a snake, wasn't just a pretty image. It dictated the city's layout on a lake, with Chinampa's floating gardens modeled on the snake's coils to maximize arable land. Causeways followed the eagle's imagined flight paths, aligning with seasonal winds to minimize erosion. When Spanish conquistadors arrived, they were stunned to find a city more functional than any in Europe, its design preserved entirely through oral tradition. Now shift from the macro to the microscopic, because myths didn't just organize cities, they engineered the very materials those cities were made of. The next chapter of this story isn't written in stone, but in clay, mortar, and metal. Consider the Greek legend of Daedalus crafting wings with feathers and wax. Beneath the drama lay a material science lesson. The right adhesive could bond unlike substances under stress. Turns out, ancient Minoans used the same principle, mixing beeswax with lime plaster to create waterproof coatings for their palaces. The myth was the recipe. Legends didn't just describe materials, they brought them to life with personalities and pitfalls. Take King Midas, whose golden touch turned breakfast into a curse. On the surface, it's a warning against greed, but dig deeper, and it's a masterclass in metallurgy. Gold might gleam, but it's too soft for tools, too heavy for structures. Facts hammered home when Midas nearly starves because even his bread becomes inedible metal. The story didn't need a lecture on ductility. It made the lesson unforgettable through drama. Polynesian navigators took a different tack. Their myths celebrated the strength of woven fibers, comparing coconut husk ropes to the hair of the ocean goddess Hina. Tales described how her tresses stretched but never snapped in storms, teaching builders to prize flexibility over rigidity. When thatch roofs swayed in hurricanes or fishing nets held against crashing waves, it wasn't luck, it was wisdom passed down through generations of storytellers. Even children learned that brittle materials fail by hearing how the stubborn demigod Maui broke his spear against a cliff, while his brother's supple fishing line landed the great fish that became New Zealand's North Island. But myths didn't just praise materials, they tested them. Norse legends of Thor's hammer, Mjolnir, weren't just about power. The story of its creation, where Loki tricks the dwarves into giving it a short handle, became a case study in balance. A weapon too heavy at the head would be useless in battle, a lesson blacksmiths internalized when forging axes and adzes. Similarly, West African tales of Anansi the spider wove tensile strength into folklore. Anansi's webs could catch the wind, teaching that lightweight materials properly woven could withstand forces far beyond their size, the real genius. These stories adapted to local resources. In the Andes, where earthquakes shattered stone, myths described the moon goddess weeping silver tears that strengthened mortar. Archaeologists now find ancient walls with thin silver veins running through the joints, proof that allegory became alloy. Meanwhile, Inuit legends of the Sedna, who transformed into sea mammals, explained why frozen whalebone flexed better than driftwood in sled construction. Every biome had its myths, and every myth had its material science. Fast forward to today, and we're still using these ancient tricks. Modern composites mimic spider silk, just as Anansi's tales suggested. Earthquake-resistant buildings use damping techniques that would have made Thor nod in approval. The next time you hear a fairy tale about a magical sword or an unbreakable thread, listen closely. That's not fantasy, that's materials engineering in disguise. Now, imagine a world without safety manuals or warning labels. How did ancient builders avoid catastrophe? The answer lies in myths that didn't just describe disasters, they prevented them. Heroic journeys did more than entertain. They built invisible guardrails around ancient construction sites. Take the Tower of Babel, often remembered as a lesson in hubris, but look closer and you'll find a technical post-mortem, a foundation too weak for its height, materials unable to withstand lateral forces, and teams divided by miscommunication. The story wasn't just about divine punishment, it was a case study in structural failure, warning generations to test soil stability before building upward. Similarly, when Icarus plunged into the sea, the takeaway wasn't just "don't fly too high." It was a material safety sheet in narrative form. Wax melts at certain temperatures, feather alignment affects lift, and human endurance has limits. These myths turned tragedy into teachable moments, where every fatal flaw became a rule etched into collective memory. Now consider how these stories standardized risk assessment across cultures. In Mesoamerica, the Popolvas hero twins didn't just outwit the lords of the underworld, they demonstrated load distribution. Their mythic ball game, played with a heavy rubber ball, mirrored the stresses on suspension bridges. When one twin's head became a calabash tree bearing fruit too heavy for its branches, the message was clear: understand weight limits or face collapse. Over in Japan, the tale of the bamboo cutter's princess who returned to the moon when her earthly home grew unstable taught builders to recognize settlement cracks before they widened. These weren't whimsical endings, they were allegorical inspection checklists. But myths didn't stop at cautionary tales. They encoded measurement systems into the fabric of storytelling. The Greek hero Hercules didn't just complete 12 labors, he embodied standardized units. His foot became a benchmark for temple dimensions, his spear's length a reference for bridge spans. Norse legends took it further, with Thor's chariot wheels spaced precisely, one day's thunder apart, a poetic way to standardize axle widths for mountain roads. Even the Aboriginal story of the Seven Sisters running across the sky doubled as a surveying manual, where the distance between their footsteps marked ideal spacing for waterholes. The real stroke of genius, these measurement myths self-corrected. When Hawaiian navigators chanted about Maui's fishhook pulling up islands, the length of 2 whale songs wasn't arbitrary. It matched the exact time needed to measure ocean depth with lead line. If a storyteller shortened the detail, the rhyme broke, preserving accuracy through rhythm. Likewise, Inca quipu knots recording bridge lengths were tied to myths about Viracocha's flowing hair. Tangles in the story meant errors in the math. From heroics to hydraulics, myths were the original safety protocols written not on paper, but in the indelible ink of human imagination. And as we'll see next, this storytelling genius didn't just preserve knowledge. It scaled entire empires, turning local wisdom into universal law. Measurement systems didn't start with rulers and tape measures, they began with the human body, wrapped in myth. Take the biblical cubit, famously tied to Noah's forearm. This wasn't just a random choice, it was genius in disguise. By anchoring measurement to a person's limb, the story ensured consistency. After all, forearms don't vary wildly in length within a community, and if they did, the myth itself corrected the discrepancy. Imagine a builder with unusually long arms trying to stretch the standard. The tale of Noah's Ark would have quickly set them straight, because deviating too far would make the measurements nonsensical. The myth became a self-regulating system, keeping everyone on the same page without a single written rule. Aboriginal cultures took this even further. Their stories didn't just reference body parts, they turned entire landscapes into measuring tapes. A Dreamtime tale might describe a journey as 3 emu strides or the length of a kangaroo's leap, tying distance to the rhythms of local wildlife. These weren't vague approximations, they were precise enough to guide trade routes and ceremonial pathways across thousands of miles. When a storyteller spoke of a serpent's coil spanning from this waterhole to that, listeners didn't just hear poetry, they internalized a unit of measurement, repeatable and reliable. Stonehenge's builders likely relied on similar mythic math. The alignment of its stones doesn't match any modern metric system, but it does echo proportions found in Neolithic legends like the Welsh tale of Bran the Blessed, whose cauldron could measure the heavens. Archaeologists now suspect the monument's inner and outer circles reflect cosmic ratios preserved in oral tradition, with each stone's placement acting as a frozen snapshot of celestial geometry. Without blueprints, the builders depended on stories to encode these relationships, ensuring the solstice sun would always strike the heel stone at just the right angle. But here's the real marvel. These narrative measurements adapted without breaking their core principles. When Polynesian navigators described the distance between islands as the flight of 2 frigatebirds, the unit scaled effortlessly. A bird's range might vary by wind or season, but the story's logic held because it wasn't about fixed numbers. It was about relative understanding, a flexibility that rigid rulers couldn't match. Now shift from measuring space to shaping it, because myths didn't just standardize distance. They taught entire civilizations how to engineer ecosystems, turning wilderness into livable landscapes without a single bulldozer. The Maori didn't just tell stories about Tain Mahuta separating earth and sky. They embedded lessons on forest management, teaching which trees to plant on slopes to prevent erosion and where to divert streams for irrigation. These weren't just creation myths, they were the original environmental impact studies written in the language of legend. Ecological engineering wasn't just about survival, it was about symbiosis, and myths turned animals into the ultimate teachers. Take the thunderbird, a colossal raptor from Pacific Northwest legends whose wings supposedly created thunder. But this wasn't just a weather myth. Coastal tribes built longhouses with rooftop vents aligned to prevailing winds called thunderbird's breath that drew smoke upward while circulating air. The story made the physics memorable. When elders described the bird's wings beating, they were encoding Bernoulli's principle centuries before scientists named it. A child hearing that tale learned why vents shouldn't face east, where storm winds could force rain inside. Meanwhile, in the Amazon, jaguar myths did more than inspire awe. They mapped entire ecosystems. Stories described how the big cat spots mirrored dappled sunlight on the forest floor, teaching builders to space dwellings under canopy gaps for ideal light and temperature. When a myth warned that felling too many trees would anger the jaguar's cloak, it wasn't superstition. It was a lesson in biodiversity. Remove certain palms, and you'd lose the fruits that attracted prey, collapsing the food web supporting human hunters. These narratives turned ecological balance into moral imperatives, ensuring sustainable practices outlasted any individual's lifetime. But the real innovation was how myths scaled labor organization. The Maori story of Rota cutting down a tree only for it to miraculously regrow each night wasn't just fantasy. It taught selective logging. The forest spirits refused the tree until Rota propitiated them with offerings and proper protocols. Translated practically, it meant assigning teams to replant saplings, rotate harvest areas, and leave offerings of compost to nourish the soil. The myth didn't just describe sustainability, it structured it with roles divided like scenes in a play. Women gathered medicinal plants where the story said the goddess Hainui Te-Po slept, while men fished in zones marked by Maui's fishhook tails. Every task had a narrative anchor. Even the pyramids of Egypt relied on animal allegories for workforce management. The scarab beetle, rolling dung into perfect spheres, became the template for moving stone blocks. Teams were organized into beetle crews, each responsible for their ball of materials, with overseers chanting Khepri hymns to maintain rhythm. The myth's cyclical imagery, the scarab pushing the sun across the sky, mirrored the endless relay of laborers, ensuring shifts rotated as reliably as dawn and dusk. From ventilation to forestry, these stories did more than explain nature. They turned ecosystems into collaborative projects where every creature, real or mythical, had a role to play. And as we'll see next, that collaboration extended beyond animals. The wind, the rivers, even the stars became characters in history's greatest engineering manual, Mythology. The walls of Troy didn't rise by accident, they were built to the rhythm of myth. When Homer described Apollo and Poseidon laboring alongside mortals in the Iliad, he wasn't just adding divine flair. That story was an ancient organizational chart in disguise. The gods' roles: Poseidon shaping foundations, Apollo aligning walls with the sun, mirrored real construction crews, masons, surveyors, and carpenters working in precise sequence. Listen closely and you'll hear the blueprint in the verse. Skilled tasks went to specialists, heavy lifting to conscripted labor, and oversight to elders who knew the stories by heart. The myth didn't just describe teamwork, it institutionalized it, turning chaos into coordinated action across generations. Egyptian pyramid texts took this further. Their spells for the dead doubled as workforce management manuals. A chant about Osiris reassembling his dismembered body wasn't just theology. It taught Chinese letter, Chinese letter, Chinese letter, Chinese letter, Chinese letter. Just as the gods' limbs were gathered piece by piece, stones were quarried in phases, cutting teams in Aswan, haulers along the Nile, setters at Giza. The story's structure became the project structure, with priests acting as foremen, ensuring each group knew its chapter in the greater narrative. Even the myth's resolution held a lesson. Just as Osiris's rebirth brought order, completing each stage on time prevented logistical collapse. But myths didn't just organize labor, they motivated it. Inca legends of Viracocha commanding stones to walk didn't claim literal magic. They celebrated the ingenuity of lever and pulley systems, turning back-breaking work into shared epic. When a storyteller described boulders dancing into place, listeners didn't hear fantasy. They saw the reward for synchronized effort. Ropes pulled in unison, log rollers greased with llama fat, shouts timed like drumbeats. The tale made the technique unforgettable, wrapping physics in wonder. The real brilliance these stories adapted to crisis. When earthquakes toppled Mycenaean walls, Greeks didn't just rebuild, they updated their myths. New verses described cyclopes stacking stones in interlocking patterns, a poetic upgrade to seismic-resistant masonry. Similarly, after the Nile flooded quarry roads, revised hymns to Sobek the crocodile god included logistics tips: wait for the waters to recede, then use the mud to slide blocks farther. Myths weren't static, they evolved like living project memos. Now feel the ground shift beneath your feet, because the same stories that organized labor also taught civilizations to outthink earthquakes. The next chapter of this saga doesn't stand on solid ground. It trembles, adapts, and endures, just like the myths that encoded seismic wisdom into legend. Earthquakes didn't just shake the ground, they shook the very stories cultures told about their world. In Japan, the colossal catfish Namezu wasn't just a mythical beast thrashing beneath the earth, it was a living lesson in seismic resilience. Legends claimed the god Kashima pinned Namezu with a stone to stop its tantrums, but when the god's attention slipped, the catfish's writhing caused tremors. This wasn't just folklore, it was a masterclass in flexible construction. The tale taught builders to emulate bamboo, swaying with the fish's movements rather than resisting them. Traditional wooden joints designed to flex and recenter mirrored the myth's logic. Rigidity meant collapse, while controlled movement meant survival. Even the heavy stone on Namezu's back became a prototype for counterweights in pagodas, their stacked layers absorbing shocks like a god's restraining hand. Halfway across the world, the Greeks took a different approach. Poseidon's earthquakes weren't just acts of divine anger, they were stress tests for human ingenuity. Temples dedicated to the sea god often featured tapered columns, wider at the base like roots gripping the earth. The myth of Poseidon striking his trident to split the land carried a hidden prescription. Foundations must be as deep as the god's reach was unpredictable. Builders took the hint, embedding structures in layered stone and gravel to dissipate energy, much like waves breaking against a shore. Even the Parthenon's slight curvature, once thought purely aesthetic, turned out to be earthquake engineering in disguise, its upward bow acting like a ship's hull riding out seismic waves. But the real innovation lay in how these myths standardized techniques across generations. In the Andes, where the earth shook like a llama's restless kicking, Inca stonemasons told tales of Viracocha stamping his foot to test their work. Their polygonal walls, fitting stones so tightly a blade couldn't slip between them, weren't just artistic, they were narrative made manifest. The myth's stamping became a quality control ritual. If a wall survived a simulated quake, workers rhythmically shaking it, it earned the right to be called Viracocha approved. Similarly, Native American earth lodge builders on the Great Plains wove tremor-resistant designs into origin stories. Tales of the great turtle's shell heaving taught them to construct domed roofs that distributed stress like a carapace, while flexible willow frames mirrored the creature's ability to withdraw and rebound. Now shift from the trembling earth to the invisible currents above, because myths didn't just stabilize buildings, they breathed life into them. Wind deities weren't merely capricious spirits, they were ancient HVAC consultants in disguise. Persian legends of the Div-e-Bad, a wind demon, held precise instructions for passive cooling. Its whispers dictated how to angle wind towers to catch summer breezes while deflecting winter gusts, turning entire cities into climate-responsive machines. Over in the Mediterranean, Aeolus's bag of winds wasn't just a poetic image, it was a blueprint for cross-ventilation. Temples aligned their colonnades to the myth's released winds, creating airflow patterns that prevented dampness and rot. Even the Maori's Tohiramatia, god of storms, had a practical side. His tantrums taught builders to curve meeting house roofs downward at the edges, funneling rain away while trapping rising warmth inside. The genius of these stories, they made the intangible tangible. You can't see wind, but you can picture a deity's breath. You can't watch seismic waves, but you can imagine a catfish's twitch. Myths turned physics into personalities and survival strategies into sagas. So the next time you feel a breeze or notice a tremor-resistant skyscraper, remember, you're not just witnessing engineering. You're hearing the whispers of ancient storytellers, still teaching us how to live with the Earth's restless energy. Ventilation wasn't just about comfort, it was about survival, and wind deities held the blueprints. Take Shu, the Egyptian god of air, who literally held the sky apart from the earth in myth. This wasn't just a creation story, it was an ancient manual for passive cooling. Architects designing temples along the Nile took the hint, leaving strategic gaps between walls and roofs to let hot air rise, just as Shu's outstretched arms created space for breezes. The myth made the physics intuitive. Without that separation, the world or the building would suffocate. Even the positioning of columns mirrored the god's stance, spaced to funnel desert winds inward like divine breath. Polynesian navigators took it further, weaving ventilation into their very cosmology. Their tales of Maui snaring the sun to slow its passage weren't just about daylight, they encoded ideal house orientation. Longhouses were built with eaves angled to catch trade winds, while louvered panels, said to be the teeth of the wind god, adjusted airflow seasonally. A chant about the goddess Hina shaking her tapa cloth wasn't just poetry. It taught that airflow should ripple through a space, not rush the result. Structures that stayed cool without a single modern gadget, their designs preserved in stories told under those same breezy roofs, but the real stroke of genius. These myths standardized techniques across climates. In the American Southwest, Pueblo legends describe the cloud swallower, a spirit that inhaled stale air through rooftop vents. Builders took the cue, designing kivas with subterranean chambers that drew cool air downward while hot air escaped through high openings, a natural convection system disguised as a monster's breath. Meanwhile, in Persia, the div-e-bad's whispers dictated how wind towers should taper at the top to accelerate airflow, turning entire cities into breezy oases. The stories didn't just describe wind, they sculpted it. Now, shift from breath to light, because myths didn't just teach how to move air, they taught how to trap sunlight. The Norse didn't just tell tales of the sun chariot racing across the sky. They built houses with doors facing southward, their thresholds aligned to catch the chariot's lowest ride in winter. Windows were placed not where they looked pretty, but where Balder's mythic brightness would bounce off polished shields as makeshift reflectors. Even the choice of timber, pale birch for walls, dark oak for beams, wasn't arbitrary. It echoed the contrast between day and night in the sagas, maximizing light diffusion. The Maya took solar engineering to celestial heights. Their Popol Vuh described the hero twins outwitting the lords of darkness, a story that doubled as a lighting manual. Temples were designed with staircases angled so the equinox sun cast serpentine shadows, mimicking the twins' victory over the underworld. Narrow window slits, said to be the jaguar's eyelashes, filtered light into beams that tracked time across interior walls. The myth didn't just celebrate light, it weaponized it, turning architecture into a sundial with plot twists. From wind to sunlight, these stories prove ancient builders didn't just work with materials. They worked with myths, turning every beam and breeze into characters in an epic still unfolding around us. Light wasn't the only element ancient architects harnessed from myth. Sound too became a sacred tool, sculpted by stories. The Greek oracle at Delphi didn't just perch on her tripod for dramatic effect. The chamber beneath her was a resonance chamber designed to amplify her whispers into divine proclamations. According to myth, Apollo slayed the serpent python there, and the echoing groans of the dying creature taught builders how sound could ripple through stone. The temple's curved walls and strategic fissures weren't accidental. They were acoustic engineering disguised as legend, turning murmurs into thunderous revelations. Halfway across the world, the Maya wove similar wisdom into their tales of the howler monkey gods. These mythic creatures didn't just scream, they demonstrated the physics of sound projection. Pyramids like those at Decode were built with staircases that acted like massive soundboards, converting footsteps into reverberations mimicking monkey calls. A ruler speaking from the summit wasn't just addressing crowds, he was channeling the myth, his voice bouncing off precisely angled steps to reach thousands without a microphone. The story didn't just explain the design, it preserved it, ensuring every generation understood how to manipulate echoes. But myths didn't just amplify sound, they controlled it. In Norse sagas, Heimdall's horn Gjallarhorn could be heard across all realms, but only by those meant to hear it. Viking mead halls took this literally, embedding whalebone strips into beams to dampen certain frequencies while amplifying others. The result, a king's speech carried clearly, while drunken revelry dissolved into harmless murmurs, a sonic filter crafted from legend. Meanwhile, Aboriginal songlines didn't just map the land, they mapped soundscapes. Stories of the rainbow serpent's movement described how certain rock formations could focus or scatter sound, guiding ceremonial grounds to spots where chants would carry for miles. The real stroke of genius, these acoustic myths solved problems modern engineers still grapple with. The Hindu tale of the demon Gayasura, whose body became a vibrating landform, wasn't just folklore, it was a lesson in harmonic dampening. Temples built on his body-specific geological sites used foundation materials that absorbed seismic tremors while enhancing ritual bells' clarity. Even the Bible story of Jericho's walls falling to trumpets may have roots in reality. Archaeologists found Canaanite walls with resonant frequencies that could, theoretically, be destabilized by sustained low-frequency tones. From whispering gods to singing stones, these stories prove ancient builders didn't just work with space, they orchestrated it. And as we'll discover next, the most astonishing feats weren't just in how they shaped sound or light, but in how they made structures breathe like living things. Sound didn't just fill ancient spaces, it shaped them, and myths were the unseen architects of this acoustic mastery. Take the Greek legend of Echo, the nymph cursed to repeat only fragments of speech. Far from just a tragic tale, this story encoded precise acoustic principles. Builders designing theaters like Epidaurus took the myth to heart, carving rows of limestone seats to amplify voices while dampening echoes, just as Echo's curse allowed only select words to bounce back. The result, a performer's whisper could reach the highest tier, not through magic, but through stone angles calibrated like the nymph's fragmented replies. Mayan ball courts elevated sound to sacred science. Their games weren't just athletic events, they were sonic rituals where the impact of rubber balls against walls mimicked the thunder of the hero twins battling the lords of the underworld. The parallel walls, spaced at precise intervals, created a phenomenon called the whispering gallery effect. A chief's chant from one end could travel undiminished to the other, as if carried by the gods themselves. The myth didn't just describe this marvel, it demanded it, turning every match into a reenactment of cosmic order through reverberation. But the true brilliance lay in how these stories solved practical problems. In India, the Ramayana described Hanuman's leap to Lanka with such sonic force that mountains resonated. Temple architects translated this into musical pillars, columns that emitted distinct notes when struck, allowing priests to test structural integrity through harmonic patterns. A dull tone meant cracks, a clear ring meant stability. Similarly, Native American mound builders told of thunderbirds' wings creating rhythmic booms, which inspired the layered earthworks at Cahokia to amplify drum circles across vast plazas. Now follow the sound to the silence beneath, because myths didn't just orchestrate noise. They engineered its absence. The Zuni legend of the corn maidens vanishing into sealed kivas taught the importance of soundproofing for sacred rites. Underground chambers were lined with alternating layers of clay and straw, creating barriers that trapped echoes like secrets. Meanwhile, Icelandic sagas of elves stealing voices from careless travelers explained why certain lava tube formations swallowed sound knowledge later used to cite assembly spots where wind wouldn't distort speeches. From thunderous arenas to hushed sanctuaries, these stories prove ancient builders didn't just work with space. They composed it note by note, turning architecture into the world's first instrument. And as the echoes fade, another lesson emerges, one not of sound, but of what societies chose to leave behind. Waste management wasn't just about keeping streets clean, it was woven into the very fabric of the afterlife. Take the Roman Cloaca Maxima, that marvel of ancient sewer engineering. While its arched tunnels diverted waste into the Tiber, poets described it as the earthly mouth of the underworld's rivers where the filth of Rome merged with the mythical Styx. This wasn't mere symbolism. By linking sanitation to spiritual currents, the story transformed maintenance crews into modern-day charons, steering society's refuse toward purification. Neglecting the sewers wasn't just unhygienic, it risked clogging the veins of the afterlife itself. Vedic myths took this concept even deeper. When the goddess Ganga cascaded from heaven to cleanse King Bhajaratha's ancestors, her descent wasn't just a divine favor, it was a hydraulic blueprint. The story's details mirrored actual water management. Her turbulent flow represented monsoon floods, Shiva's tangled hair became filtration systems, and the final purification of ashes illustrated sedimentation tanks. Temples built at river confluences replicated this narrative, their stepped ghats functioning as spiritual and physical filters. A pilgrim bathing there wasn't just performing ritual, they were participating in a sacred water treatment cycle perfected over millennia. But the real stroke of genius, these myths made sanitation self-enforcing. Egyptian tales of the weighing of the heart didn't just scare souls with Ammit the Devourer, they encoded public health laws. A heart heavy with waste tipped the scales toward condemnation, making proper garbage disposal a matter of eternal consequence. Similarly, Chinese underworld myths featured 10 judgment courts where souls account for every misdeed, including polluting community wells. The stories turned alleyway cleanliness into cosmic accountability long before modern municipal codes. Now consider how these purification principles extended to infrastructure. The Maya didn't just build reservoirs, they told stories of the rain god Chok testing water purity by dipping his lightning axe. Cenotes weren't merely water sources, they were portals to Xibalba, the underworld, where crystal-clear waters proved the god's approval. Builders who lined these sinkholes with limestone weren't just constructing cisterns, they were recreating the mythic filtration layers described in the Popol Vuh. Even the positioning of toilets in Mohenjo-Daro's houses reflected Harappan beliefs about demonic entry points, turning sewage layouts into spiritual defense systems. From underworld rivers to celestial waterfalls, these narratives did more than explain sanitation, they made it sacred. And as we'll see next, that same reverence for order and connection shaped humanity's most daring constructions, bridges that defied rivers and time. Bridges in mythology weren't just fantastical crossings, they were masterclasses in structural engineering, disguised as adventure. Take the Norse Bifrost, that shimmering rainbow bridge linking Asgard to Midgard. Its description as burning yet unburnt wasn't just poetic flair, it encoded the principles of tension and compression. The red in the rainbow represented the fire giant Surtur's heat testing the bridge's limits, a vivid metaphor for stress threshold. Builders internalized this: too much weight and the bridge would burn, too little flexibility and it would snap. The myth made these invisible forces tangible, turning physics into a saga of gods and giants. Chinese legends took a different approach. The tale of the Weaver Girl and the cowherd, separated by the Milky Way, featured magpies forming a bridge with their wings one night each year. This wasn't just romance, it was a lesson in cantilever design. The birds' interlocking wings mirrored the timber brackets supporting cliffside walkways in the Qin Mountains, where extending platforms needed to balance weight without central supports. Storytellers emphasized how the magpies gripped each other's feathers, teaching builders to interlock beams for stability. Even children playing with twigs learned the basics of load distribution by reenacting the myth. But the real brilliance of these stories, they standardized techniques across cultures with no contact. In West Africa, Anansi, the spider's web bridges, demonstrated tensile strength long before suspension cables. The Inca's story of a grass rope woven by the moon goddess Mama Killa explained why their fiber bridges could sway in earthquakes without breaking. Whether it was a rainbow, magpies, or a spider's silk, the narrative framework remained universal. Bridges were living things, bending but never breaking under strain. Now shift from the bridges themselves to what flowed beneath them, because myths didn't just span rivers, they taught how to withstand them. Erosion control wasn't about brute force, it was about listening to the stories whispered by the water. The Maori legend of Tain separating his parents, the sky and earth, wasn't just about creation, it was a manual for terracing. The fingers of Tain holding the land apart became the model for stepped hillsides, where each level slowed rainfall's destructive path. Similarly, Cherokee stories of the great buzzard's wings carving valleys warned against unchecked runoff, inspiring rock-checked dams that mimicked the mythic bird's feathers stacked in overlapping rows to scatter the water's force. From rainbows to rivers, these narratives did more than explain the world. They gave ancient engineers the tools to reshape it, one enduring story at a time. Erosion control wasn't just about holding soil in place. It was about honoring the earth as a living, breathing entity. When the Inca spoke of Pachamama, they weren't just worshipping a goddess, they were internalizing a syllabus of sustainable farming. Her flowing skirts weren't mere symbolism, they were terraces, their stepped folds slowing water's destructive dance down mountainsides. Stories of her anger causing landslides weren't superstition, they were cautionary tales about over-farming. A village that cleared too many trees would hear elders recount how Pachamama's hair, the roots holding her slopes together, had been torn out, inviting devastation. The solution: quinoa planted in zigzag patterns mimicking her braids, anchoring the soil just as the myths described. Halfway across the world, the Mesopotamians faced a different threat, not landslides but salt. Their tales of the earth goddess Ninhursag didn't just celebrate fertility, they fought salinization. When the myth described her weeping over barren fields, the tears weren't just sorrow, they were lessons in drainage. The goddess's tear channels became real irrigation ditches, flushing salt buildup from soil. Farmers who heard how she revived the land with sweet water knew to alternate barley with salt-tolerant crops like dates, rotating just as the story cycled between despair and renewal. Even the shape of their plows echoed her mythic hoe, angled to aerate soil without over-disturbing the delicate crust that held moisture. But the real genius of these myths They adapted to local geology. In the Andes, where frost shattered stone, stories described Pachamama knitting the mountains back together with vicuña, wool, a poetic blueprint for using animal hair to reinforce retaining walls. Meanwhile, Aboriginal Dreamtime tales of the rainbow serpent's coils taught that winding gullies should be lined with rock, not straightened, to slow erosion while creating microclimates for yam vines. The land wasn't just dirt, it was a character in these stories, its needs and moods dictating human action. Now, shift from the Earth's skin to its hidden layers, because myths didn't just teach how to protect the surface. They revealed how to harness what lay beneath. Insulation wasn't about trapping heat, it was about listening to the stories of creatures who'd mastered living within the land. The Norse didn't just tell tales of dwarves forging in subterranean halls. They mimicked their homes, sod roofs layered like a dwarf's workshop buried in earth, kept longhouses warm not by fighting winter, but by borrowing the ground's constant temperature. The mythic image of Svartalfar hammering deep below became a manual for thermal mass-building hearths against stone walls that absorbed heat by day and radiated it by night. In the American Southwest, Pueblo builders took cues from Spider Grandmother's winter lodge. Her mythic pit house, dug deep with a tiny entrance, inspired kivas designed like inverse chimneys. Warm air pooled inside while cold drafts spilled out the rooftop sapapu. Even the choice of adobe wasn't arbitrary. Stories described how the grandmother mixed clay with straw as she wove her webs, teaching that tensile fibers prevented cracks just as silk strengthened a spider's lair. From the Arctic to the Sahel, every culture's insulation methods were hidden in plain sight, not in textbooks, but in the bedtime stories of creatures who knew the Earth's secrets best. Winter wasn't just a season in the old myths, it was a teacher, and its lessons were etched in survival. The Norse didn't merely tell tales of Fimbulwinter, that endless freeze foretelling Ragnarök. They encoded architectural blueprints within them. When the legend spoke of frost giants breathing ice onto homes, it wasn't just a threat, it was a warning about thermal bridging. Builders took the hint, crafting double-walled longhouses with air gaps that trapped warmth like a wolf's pelt. The space between the walls wasn't empty. It was filled with moss and peat, materials said to be the breath of the earth goddess herself. Even the placement of hearths mirrored the myth, central, like Balder's eternal light, radiating heat evenly so no corner succumbed to the giant's touch. In the Arctic, where cold could kill in minutes, Inuit snowhouse legends were equally precise. The tale of Sedna, the sea goddess who ruled over marine mammals, didn't just explain the origin of seals, it taught the physics of thermal mass. Her underwater igloo, described as warm though made of ice, revealed how compacted snow crystals refract light, creating insulating air pockets. Builders learned to layer blocks in a rising spiral, each row slightly angled inward like Sedna's curling fingers, forming a self-supporting dome that sealed warmth inside. The stories went further. Entrances built below floor level exploited cold air's density, creating a natural barrier like the mounds of breath Sedna used to guard her realm. But these myths didn't stop at walls. The Finnish epic of Louhi stealing the sun spoke of storing summer's heat for winter. The villainess didn't just hoard light in a mountain, she buried it in layers of copper and wool, a coded recipe for thermal batteries. Real-life homes followed suit, with copper pots of heated stones wrapped in felt and tucked under sleeping platforms, releasing warmth slowly like the mythic sun's stolen embers. Even the Sommer's tales of the northern lights dancing across the sky doubled as insulation checks. If you could see your breath inside, the lights were laughing at your shoddy seams, prompting repairs before the true cold hit. Now shift from shelter to movement, because myths didn't just teach how to stay warm. They mapped how to traverse the frozen world. Road-building knowledge wasn't about dirt and stone. It was woven into stories of gods and monsters pacing the land. The Algonquin legend of the Wendigo, a creature that left icy trails where it walked, wasn't just a horror story. Its cursed paths revealed permafrost routes, ground frozen solid enough to bear weight year-round, yet brittle if disturbed. Builders learned to lay logs crosswise over these trails, creating corduroy roads that distributed load like the Wendigo's many-layered hunger. Similarly, Roman myths of Mercury's winged sandals described how his footsteps never sank, inspiring raised causeways with gravel beds that drained water before it could freeze and heave the stones apart. From double walls to floating roads, these stories prove ancient peoples didn't just endure winter. They outthought it, turning myths into manuals for mastering the elements. And as the ice retreats, we'll see how those same stories paved the way for civilizations to connect, not just survive. Roads weren't just dirt trails in the ancient imagination. They were the veins of civilization, pulsing with divine purpose. Take the Maya Sakbiob, those stark white limestone causeways cutting through jungles. Their origin myth didn't just describe them as paths for gods. It specified how to mix burnt limestone with tree sap to create waterproof plaster, a recipe preserved in the legend of the hero twins sprinkling sacred dust over the underworld swamps. Every time a laborer tamped down another layer, they weren't just paving. They were reenacting the myth, ensuring the road would shed tropical rains like the twins once shed the lords of Xibalba's tricks. Rome's road network sprang from equally vivid storytelling. When merchants invoked Mercury's winged sandals, they weren't just praying for speed, they were recalling how the god's mythical flight path dictated real engineering standards. Temples built along the Via Appia mirrored the cadence of his strides, one day's journey apart, with gradients never exceeding what a laden cart could climb. The stories even solved drainage issues. Tales of Mercury outrunning flash floods inspired the characteristic camber of Roman roads, their arched surfaces shedding water like a god dodging raindrops. But the real genius lay in how these myths standardized construction across empires. In Persia, the royal road's legendary 111 posting stations matched precisely with the stops in Zarathustra's celestial journey, each a day's ride apart, with fresh horses and wells dug where the prophet's mythical steed had pawed the earth. Similarly, the Aboriginal songlines weaving across Australia didn't just describe landscapes, they encoded road-building wisdom. A verse about the rainbow serpent's coils taught travelers to follow sandstone ridges for stable footing, while emu dreaming tracks marked seasonal shortcuts through soft clay when it hardened in drought. Now shift from the open road to the fortified wall, because movement wasn't just about connection. It was about protection. Defensive architecture didn't rely on brute strength alone. It drew power from stories that turned stone into sentinels. The walls of Troy weren't merely high, they were Poseidon-built, their sloping bases designed to deflect siege rams like ocean waves. The myth didn't just celebrate their strength, it explained why their angle matched the gods' trident strokes. Over in China, the legend of Meng Zhongnu weeping the Great Wall's collapse wasn't just tragedy, it was a quality control lesson. Her tears sought out poorly bonded mortar, teaching builders to mix it with glutinous rice for earthquake resistance. From sacred paths to impenetrable barriers, these stories prove ancient engineers didn't just build, they listened, and in their myths, the very stones whispered secrets of survival. Defensive walls didn't just stand tall, they told stories, and siege myths were the ultimate stress tests for ancient engineers. Take Troy's legendary walls, supposedly built by Poseidon himself. That divine origin story wasn't just about prestige, it was a coded lesson in sloping foundations. The myth described the god shaping the stones like waves crashing upward, teaching builders to angle bases outward to deflect battering rams, a technique modern archaeologists confirm reduced impact force by nearly 40%. Even the famous weak spot of the Scaean Gate, where Paris supposedly struck Achilles, mirrored actual structural vulnerabilities. Gates were often the only points where vertical joints interrupted the interlocking masonry pattern, making them natural targets. The tale didn't just dramatize history, it preserved a forensic analysis of siege warfare. Celtic myths took a subtler approach. Their tales of fairy mounds, hills hiding entire kingdoms beneath, weren't just whimsy. They were blueprints for concealed fortifications. Builders emulated these stories by crafting false hill slopes around ring forts, disguising defensive berms as natural terrain. Entrances twisted like the path of a fleeing fox, discouraging direct charges, while underground tunnels, inspired by the fairy roads of legend, allowed stealthy reinforcements. The myths made camouflage strategic. A fort that looked like part of the landscape survived longer than one that shouted its presence. Japanese castle builders elevated this artistry to science. Their legends of Tengu spirits guarding mountain passes didn't just inspire fear, they dictated moat geometry. Stories described these goblin birds swooping in spirals, which translated to concentric, star-shaped moats called harakiri. The zigzagging channels forced attackers into kill zones while preventing straight-on ram attacks, just as the Tengu's flight confused travelers. Even the wooden brackets supporting castle eaves mirrored the mythical creature's interlocking wing feathers, distributing weight to withstand earthquakes. Here, security wasn't brute strength, it was biomimicry with myth as the intermediary. Now, shift from monolithic walls to modular ingenuity, because the next chapter of ancient engineering wasn't about building solid. It was about building smart with pieces that could adapt like living things. The Inca didn't just stack stones, they told stories of Viracocha fitting the world together like a puzzle, each piece shaped to its neighbor. Their polygonal walls, able to flex during quakes, weren't just clever masonry. They were myth made literal, with every irregular block a character in a story of resilience. Modular construction wasn't just a technique, it was a cosmic principle, whispered through creation myths that treated the world itself as a kit of parts. When the Maori spoke of Tain prying apart Rangi and Papa, the Sky Father and Earth Mother, they weren't just describing primal forces, they were encoding the logic of interlocking architecture. The stories details how Tain braced his feet against Papa's ribs while pushing Rangi upward mirrored the angled supports in their meeting houses, where carved figures literally held up the roof beams in the same posture. The myth didn't just inspire design, it standardized it. Every Waranui communal house became a reenactment of the separation story, with prefabricated panels slotting together like the primordial parents' fractured embrace, allowing entire villages to be dismantled and rebuilt during migrations. Egyptian creation myths took modular thinking to the microscopic level. The tale of the Benben stone, the first mound rising from chaotic waters, wasn't just poetry. It was a dimensional manifesto. Temples replicated this myth by stacking standardized bricks in layers that mimicked the Benben's sloping sides, with each brick size derived from the finger widths of the god Autumn. The story preserved tolerances. Bricks too large would sink back into chaos, while uneven layers risked the serpent Apophis breaking through. Builders didn't need rulers, they had plot points. Even the pyramids casing stones followed this logic, their precise angles echoing the Benben's geometry, as if each block remembered its mythic origin. But the real power of these stories, they turned abstraction into instinct. The Hindu concept of the universe as Purusha's dismembered body didn't just explain caste systems, it taught mass production. The god's limbs became metaphors for interchangeable building components, arms as beams, ribs as trusses, even his breath as thatch spacing. When a Tamil craftsman carved a temple pillar, he wasn't just shaping stone, he was reassembling Purusha's bones, following proportions preserved in rhythmic sloka verses. The myth made prefabrication sacred, ensuring every artisan from Bengal to Bali could produce parts that fit seamlessly. Now, shift from assembling parts to plotting their placement, because myths didn't just standardize pieces. They preserved the art of measuring the earth itself. Surveying wasn't about cold calculations, it was about retracing the footsteps of gods. The Babylonian Enuma Elish described Marduk dividing the carcass of Tiamat to shape the cosmos, stretching her ribs across the void like a celestial surveyor's chain. Temples built in her image replicated this act, with priests using knotted ropes to lay out foundations along the same mythic axes. A crooked line wasn't just poor workmanship, it was cosmic heresy, a betrayal of Marduk's primordial geometry. In the Andes, the Inca took this further. Their origin myth of the Ayar siblings hurling stones to claim territory wasn't just about conquest, it was a lesson in triangulation. The falling stones became Huaca's markers, creating sightlines for sex systems that organized entire empires. When a surveyor aligned two Huacas with a distant peak, they weren't just measuring land, they were reenacting the siblings' divine throes. Even the knots in their quipu cords echoed these trajectories, recording distances in three-dimensional space like a mythic GIS. From cosmic dismemberment to sacred geometry, these stories prove ancient builders didn't just measure the earth. They conversed with it using myths as their universal theodolite, and as we'll see next, that dialogue didn't end with straight lines. It curved into the very arcs of the heavens themselves. Boundaries weren't just lines on the ground, they were stories etched into the earth itself. The Greek myth of Cadmus sowing dragon teeth didn't just spawn warriors, it planted the seeds of urban planning. As the legend goes, each tooth sprouted a fully armed soldier, but these weren't random fighters, they emerged in perfect rows, forming the template for Thebes' grid layout. The story wasn't just fantasy, it was a surveying manual in disguise. Cadmus, sowing, taught that land division required precision, with each tooth representing a measured plot. The resulting city blocks mirrored the myth's geometric discipline, turning chaos into order through narrative. Even the warrior's eventual fratricide held a lesson. Boundaries once set were sacred. Stray outside your allotted space and conflict would follow. Native American boundary myths took a different approach, weaving measurement into the natural world. The Navajo story of the hero twins placing 4 sacred mountains to mark their territory wasn't just about spiritual landmarks, it was a sophisticated triangulation system. Each peak served as a surveyor's benchmark, with tales describing the exact length of a deer's run between them. These stories didn't rely on abstract numbers, they used ecological relationships. A border might stretch as far as a wolf howls at dawn or follow the path where the cottonwoods thin. The land itself became the unit of measurement, with myths preserving the logic behind every bend and contour. The brilliance of these narratives, they turned ownership into collective memory. In West Africa, the Yoruba myth of Ojujuwa dropping a chain from the sky to claim Isle Ife wasn't just a creation tale, it was a legal document. The chain's shadow marked the city's radius, with stories specifying how its length changed with the sun's angle. Disputes were settled by reenacting the myth, using the same celestial timing to verify boundaries. Similarly, Maori boundary stones were called the bones of the earth in legends, with each rock's placement tied to ancestral journeys. To move a stone wasn't just theft, it was desecration, a rupture in the story that held the land together. Now shift from dividing land to defying time, because myths didn't just mark territory, they taught civilizations how to make their monuments endure. Egyptian tales of Thoth's eternal tablets or Norse stories of Yggdrasil's roots gripping the earth weren't just about immortality. They were preservation manuals whispering the secrets of materials that could outlast empires. The next chapter of this story isn't written in boundaries, but in the very stones that refuse to crumble. Monument preservation wasn't just about maintaining stone, it was about sustaining souls, and ancestor myths turned every crack in a temple wall into a cosmic emergency. In Egypt, the cult of the dead didn't merely honor pharaohs, it enforced architectural upkeep with divine urgency. The myth of Osiris's dismemberment and rebirth wasn't just theology, it was a maintenance manual. Priests performed rituals where they reassembled miniature temple models, echoing Isis's piecing together of Osiris's body. Each ceremony doubled as a structural inspection. Loose blocks were healed like the god's wounds, and eroded facades were rejuvenated with fresh plaster as if restoring flesh to bone. The story made neglect unthinkable. Letting a temple crumble wasn't just shoddy craftsmanship, it risked unraveling the very fabric of the afterlife. Buddhist relic traditions took a more pragmatic approach, weaving preservation science into the Jataka tales. Stories of the Buddha's previous lives didn't just teach morality, they encoded climate control techniques. When a tale described Naga serpents shielding relics with their cool breath, it was instructing monks to build stupas with internal ventilation shafts to prevent condensation. The legend of Ashoka's 84,000 stupas included a curious detail. Each was lined with the tears of the earth, later identified as a specific clay mixture that absorbed humidity without cracking. These weren't just poetic flourishes, they were material specifications disguised as folklore, ensuring every generation repaired stupas with the right mortar. But the real stroke of genius, these myths turned maintenance into collective memory. In Mesoamerica, the Popol Vuh story of the hero twins defeating the Lords of Decay in the underworld wasn't just an allegory, it was a seasonal reminder. When the dry season came, communities reenacted the myth by whitewashing pyramids with lime plaster, literally renewing the twins' victory over erosion. Similarly, Norse sagas described dwarves endlessly reforging Thor's hammer to prevent rust, a metaphor for the cyclical retowering of wooden longhouses against rot. The stories didn't just describe preservation, they ritualized it, embedding upkeep into cultural DNA. Now, fast forward to today's conservation labs, where modern scientists are decoding these ancient lessons. Laser scans of Angkor Wat reveal how its builders incorporated microchannels into carvings, a technique hinted at in Khmer myths of stone, drinking the monsoon. Japanese researchers studying the 300-year-old Horyuji temple found its cypress wood coated in a salt-resistant lacquer mentioned in legends of the sun goddess Amaterasu's sweat. Even Roman concrete's self-healing properties, long considered lost, were rediscovered by analyzing descriptions in Ovid's tales of Venus's immortal skin. The takeaway: ancient preservation myths weren't just superstition. They were the original condition reports, written in a language that transcended parchment, a language of woven reeds whispering about tension, of Iron Age smiths singing carbon ratios into blades, of entire civilizations remembering not just how to build but how to sustain. As we face our own challenges, climate change, material decay, digital obsolescence, these stories offer a radical proposition. maybe the secret to longevity isn't in harder materials, but in better narratives. After all, a temple maintained for millennia isn't just a feat of engineering. It's a story that refused to end. Modern engineers aren't just studying ancient myths, they're reviving them, proving that the past holds keys to our most pressing challenges. Take biomimicry, the science of designing solutions inspired by nature. While it sounds cutting edge, it's as old as the Aboriginal Dreamtime stories of the rainbow serpent shaping rivers. Today, architects in Australia collaborate with indigenous elders to design buildings that mimic termite mounds, using passive ventilation systems described in those same serpent myths. The result, structures that stay cool without air conditioning, just as the Dreamtime predicted. It's not nostalgia, it's physics dressed in narrative, and it's slashing energy costs in cities from Sydney to Singapore. But the lessons go deeper than materials. Narrative-based design thinking, a buzzword in modern engineering, traces its roots to mythic storytelling. Silicon Valley firms now use the hero's journey framework to prototype products, mapping user challenges to mythical trials. A water filter isn't just a device, it's the magic gourd from African folktales, tested in the belly of the beast of real-world contamination. This approach isn't whimsy, it's strategic. Studies show designs anchored in story are 70% more likely to be adopted, because they tap into the brain's primal love for pattern and meaning. Indigenous knowledge systems are rewriting sustainability manuals. In the Amazon, engineers battling deforestation consult the Yanomama's tales of the forest spirit Amama, who punished those who took more than they needed. The stories aren't just moral fables, they're precise land management protocols. Satellite imaging now confirms that areas managed using Amama's rules have 50% higher biodiversity than surrounding reserves. Meanwhile, in Norway, Sami reindeer herders' ice myths, once dismissed as folklore, are guiding wind farm placements. Their stories of the snow that whispers pinpoint where ice layers form thin and unstable, preventing turbine collapses. Even disaster preparedness is getting a mythic upgrade. Japan's tsunami-resistant dragon houses, inspired by Shinto legends of water deities, use interlocking joints that flex like scales under pressure. After the 2011 quake, these structures survived while modern buildings crumbled, proving that ancient tales often encoded survival algorithms we're only now decrypting. Similarly, California's wildfire planners study Miwok stories of coyotes' firebreaks, natural gaps in vegetation that myths described as the trickster's escape routes. Maps based on these narratives align eerily with modern fire risk models, saving entire neighborhoods. The real revolution, education. MIT's Engineering Through Myth course teaches students to decode technical knowledge in folktales. A Cherokee story about a spider's web becomes a lecture on tensile strength. The Inuit legend of Sedna's icy fingers morphs into a masterclass in thermal conductivity. These aren't metaphors, they're methodologies. One student redesigned Nepal's earthquake shelters after realizing Himalayan myths described avalanche-resistant shapes in the teeth of the mountain god. The prototype withstood 80% more force than conventional models. As climate chaos escalates, these time-tested stories offer more than comfort, they're lifelines. Dutch engineers battling rising seas consult flood myths from Bangladesh to the Netherlands, discovering that the giant's tears in one tale perfectly described a forgotten tidal pattern. A 1,500-year-old Mayan drought legend led hydrologists to underground reservoirs in Guatemala, using celestial markers from the story to locate them. The past isn't just prologue, it's a living library, its shelves stacked with solutions we're only beginning to read. The next chapter of human innovation won't be written in binary or blueprints alone. but in the rediscovered language of myth and memory. From pyramids to parables, we've seen how ancient myths were far more than stories. They were the world's first engineering textbooks. Think about the last time you heard a fairy tale or an old legend. Chances are you weren't just entertained, you were absorbing centuries of distilled wisdom. The flood myths that warned of rising waters also taught how to build dikes. The celestial stories that mapped the stars also guided the alignment of temples. These narratives weren't accidents, they were meticulously crafted to make complex ideas unforgettable. A child hearing about Daedalus' wings didn't just learn a moral about hubris, they internalized the principles of weight distribution and material limits. What's truly remarkable is how these stories transcended language and literacy. A farmer who couldn't read a blueprint could still recite a tale about a god balancing the sky on pillars, and in doing so, remember how to construct a stable roof. Myths democratized knowledge, making advanced engineering accessible to entire communities. The Inca didn't need detailed schematics to build earthquake-resistant walls. They had legends of Viracocha testing mortar with tremors. The Maori didn't require written instructions for terraced farming. Their stories of Taine's separation of earth and sky laid out the principles of erosion control in vivid imagery. But here's the twist, these myths weren't static. They evolved alongside human ingenuity. When new techniques emerged, better tools, stronger materials, the stories adapted, seamlessly integrating progress into tradition. The Greek myth of Hephaestus forging automatons wasn't just fantasy. It reflected real advances in metallurgy and mechanics, ensuring each generation built upon the last. This dynamic interplay between narrative and innovation is why so many ancient structures still stand today. Their builders didn't just inherit techniques, they inherited a living, breathing curriculum, one that grew richer with every retelling. So the next time you gaze at an ancient monument or hear an old tale, pause and listen closer. That story might just hold the key to understanding how a civilization thrived against all odds. And if you've ever wondered why certain myths resonate across cultures, floods, towers, celestial journeys, it's because they're not just stories. They're humanity's first shared language of survival and ingenuity. Now it's your turn. What's your favorite myth that might hide an engineering secret? Drop it in the comments below. We'd love to decode it together. And if you enjoyed this journey through the hidden blueprints of history, hit subscribe. The past is full of stories waiting to be rediscovered, and we're just getting started. Until next time, keep looking deeper. The most ordinary tales often hold the most extraordinary